this computer. Wide floating meeting controls. Fine. So let's quick recap of 5 to 10 minutes. So you remember what is the concept behind clustering is, right? So a group of laptop connected via internet or Ethernet, and it may be 2, 4, 10, 12, 100,000, doesn't matter. But if it's a group of laptop and Hadoop is installed, then we can call it as a Hadoop cluster. Cluster means a group of laptop connected together. That particular, if they are connected together, then we can call it a cluster. When Hadoop is installed in that, we call it normally HDFS cluster, which is actually our field of study or our field of training or our field of future. So I told you how to, and then there is a gateway laptop for each cluster, and that gateway laptop is connected with that Hadoop cluster, HDFS cluster, and this is done by admin people. You need not to worry about it. Everything is being done by admin people, and the whole setup is done by admin people. All those configuration settings, block size in the configuration file, what will the block size, minimum block size, everything will be configured by admin people. You need not to worry. Only the way you can connect to that gateway laptop is via put your mobile system. There is two softwares from your PC, the PC you are sitting on, then to connect to that gateway laptop, which is controlled by admin people, and you never know the place of it. It might be in India, it might be in another data center where everything is, they are doing all these admin stuffs, infra stuffs. So you only need another software installed in your laptop, that is Putty. No, that is that in your laptop, that is Putty, and via Putty you need to put your you need to give your IP address or host name to connect to that gateway laptop. So connection established between gateway laptop. If you want to communicate to gateway laptop, then you have to use Linux commands. The reason being, the gateway laptop OS is a Linux system. It's a Linux OS, so it will understand Linux commands. You need to communicate to Hadoop cluster, HDFS cluster, then you have to use Hadoop commands. And in every cluster, there are two things fixed. One is name node, another is secondary name node. Rest all are data nodes where data is going to be stored. This name node and secondary name node are used to control or used to maintain that FS image and used to control these data nodes. They are the control points. I will tell you the purpose of secondary name node today. You understand the name node in which FS image is inside name node, and FS image gets all the details from name node gets all the details from FS image, and accordingly it works. So this part is clear. Then we have started understanding how Hadoop actually works, how the block splits works, how the replica works. We understood that for Hadoop, by default, Hadoop duck cutting has designed it. The minimum block size will be 128. If it's 256, then two block size, 128 and 128. If it's less than 256, then 128 plus whatever there is, that will be less than 128 itself. So that's how the blocks are being divided, and there are replicas of it. There will be three copies of it. That is must. That is the rule set by Hadoop. The tool will do the replica and store it in three data nodes, three different data nodes. Same copy will not be stored in same data node. Clear? There will be three copies in three data node. Just because if one data node we lose, we have two more copies in two different data nodes. So that's how the cutting had designed it, and there is a heartbeat time. Quick response time to let name node know that you are active. That is 3 seconds. What is the grace time? Let me know.
10 minutes.
10 minutes exactly. So till 10 minutes, if one of the data node is not responding, then name node will wait till 10 minutes before doing anything. Before doing anything, it will sit silently. It will observe if it starts responding or not. Maybe some network issues, maybe some internet issues, something might have happened. Maybe some that system can hang for some time. Then it will wait for 10 minutes. If it responds back, everything is fine. If it doesn't respond after 10 minutes, name node will will go to FS image, will see the same blocks which was in excuse me, which was in that node which was not responding. It will copy one and it will keep it in another data node. And if by chance that data node which was dead starts responding after 10 minutes, then name node will again push a command to delete everything. Delete everything will make it empty. Then it will bring some data or the same data it can bring, or bring some data to to diversify and to not give a single data node a lot of load. Just because some data node is totally empty, one data node is totally empty, I can share some data over there. But the end goal is to do the replica of three replicas, three copies of each data block. If my data block in gateway is splitted for 10, then 10 into 3, 30 for one, and 30 into 10, 300 copies. 300 blocks will be there. You understood? If my, I think, no, no, I went wrong here. If the gateway laptop, the block size is divided, 128, 120 divided into 10 different blocks, then this 10 single block have 3 copies. Then this 10 block have 30 copies. So 30 copies will be divided, but not a single copy will be staying in same data node. Clear till now?
Yes.
Yes, of
Okay,
course.
okay. Let me show you that doing a practical, doing via coding. Let me show you how Hadoop does it. Before 2 hours, I was trying to launch that, which I paid and take the license, IT University Lab. It wasn't responding. Let me see if it's responding now. Let me open in incognito. Google IT University Lab. This is a kind of UI for your, the way we saw Cloudera, it is a kind of, they are hosting it in UI. You can see here gateway node, right? See gateway node. Let me
Yes,
launch it. Let me launch it. If it's launching, the gateway node is launching, then I can shoot my commands. Linux commands and Hadoop commands too. Linux commands for gateway laptop, Hadoop commands for Hadoop cluster. Let me see if it's launching. I'm not sure. If it's not launching today, then definitely I'm going to give you that. Going to show you that thing in next class. How the things happens, how the block gets splitted, how you'll understand that report, everything I'll show you. It should work. I'm not sure if they are doing some deployment or something. Sunday it is no, though there are high chances. Even if you'll, a lot of application I have faced. Sunday after 12 a.m. in the night, maximum apps doesn't work properly. I have experienced with most of the UPI apps. When IRCTC goes, there is a schedule breakdown of IRCTC app. No, it's not working. There is a scheduled breakdown of IRCTC app every night. I think somewhere around 1 to 3 or 1 to 4. That time usually they deploy something. That time
Yeah.
prod
Midday
environment,
it's time.
yeah, prod environment is not available. Let me try this here also. Trying logging in. Let me see if it works. If it doesn't, I will show you in the next class. Though I have the video of the Friday class, but I want to do it in front. We can wait for One more session to show it. It will take another 10 to 15 minutes max, but it's not responding right now. Not sure. Let's wait. Let's see if it's throwing any error. 90% chance it's going to throw an error. Else it would have been let us in till now. See? Okay. We'll do it in next class, or I will try to launch it while wrapping up the call to show you if it works or not. Let me close it. Okay, there is no use of it. Now we will go straight to our agenda today. Today's agenda is only single thing. Only single thing. Meta agenda is metadata management. If time permits, I will just give you an intro of Hadoop 2.0. Intro Hadoop 2.0. This is the last theory of
No,
first phase.
yesterday we were talking about
Hadoop 1.
secondary name.
Correct. I'll come to there
Oh,
only. In metadata management, till now I
okay.
haven't touched secondary name node. I will touch it today.
Okay.
In this is metadata management. It's all about FS image. I mean, FS image is a data file, right? So in IT world, we call it like metadata. We call it even a single data. We call it as a metadata, and that file name we call it as FS image. But it's a metadata management. The architecture, the concept, the fundamentals are called metadata management. We have to handle FS image that efficiently. It's a heart and soul of that name node, right? Everything image is having, right? All the details, what is staying in which node has what much space. Every single detail is with FS image. So we have to see how we can handle it properly. So we never lose our data. Clear. The purpose
Yes,
we are
sir.
going
Hmm.
to the purpose today we are going to metadata management. That means we have to manage to handle this particular FS image file so efficiently, so neatly, so accurately, so that we never lose our data. So duck cutting designed it in a different way. Before that I will just tell you. Let me open that only. I will tell you five known facts. Simple facts. Everyone knows this. Everyone know this. Five known facts. It's very common, very known to everyone. I'll go one by one. Client is important, correct? If you are working in IT company, you know how much importance we give to client. If client has sent any email, drop everything wherever you are, you have to reply them back. You have to reply them back. They are the first priority. They are giving business, so they are always prioritized. It's client. It's not like only you take it for client. If my boss is texting me, if I'm doing something, I have to reply him back. It's not exactly client, but that person who is, I mean, for whom you are working, you have to give the response back quickly and promptly. Correct? So this is normal scenario. Client is very important. Correct? If your boss asks you something, you will prioritize that thing. Whatever you are doing, you will leave it. Your boss will tell you do it first, then you'll prioritize that thing. If any request comes, response should be faster. This is a fact, right?
Yes, sir.
Response should be faster. Then we'll come to the second known fact. Every single laptop. Again, I'm telling a story, but again, I will relate it to that Hadoop system only. Don't worry. Every laptop will have a RAM and a hard disk, correct? If someone has any question why brother told hard disk, but he has written SDD, it's hard disk drive. Correct, correct. Till now clear? Every single laptop you pick it, there must be a hard disk and RAM. Else your laptop will not run. It will not run at all. If RAM is not there, you cannot open a single application itself. Clear, clear, clear. That is why during the first starting days, I asked everyone how much RAM you are having. Just because you are going to handle a big tools inside that, so it depends of your RAM, how much it can process it, how much data it can handle it. So that is the reason I asked everyone, if you are having 16 GB, then give it 8 GB. If you are having 8 GB, then give it around 4 GB to Cloudera. If you are having 4 GB, then give it around 2500 MB or something like that, for Cloudera when we created a virtual system. So Cloudera will consume that much of RAM when we launch it from our original RAM, our system RAM. Clear till now, everyone?
Yes.
Clear? Okay. Files in RAM response faster than SDD. Then no, this is not required at all. You cannot access a file if it's not in RAM. This is clear. Can you understand this?
Mm-hmm.
Ranjoy, if you are using any Excel sheet by any, you are into IT, so that is why I am telling you.
Yeah,
If you are using any Excel sheet in your code, first it will launch that Excel sheet. First, it will bring it to RAM. Then it will access those data inside that Excel sheet. Correct?
it's correct.
Correct. I am not sure if you are using that scenario, but while I am automating something and my all data like login ID, password,
Yeah, it's stored in Excel, right?
stored in Excel, but when you run the code, it will launch that. It will launch that Excel. It will bring that to RAM first. It will
Mm-hmm.
open it, then it can access it.
Yes.
Then the code will run and then it will pick it like anything. I mean, microseconds it will pick those data and it will put inside wherever you want it to put.
Yeah.
So the simple concept is, whatever files you have installed, whatever tools you have installed, whatever applications you have installed, it's in your hard disk drive. Once you open it, it comes to RAM.
Mm.
It opens and comes to RAM, then only you can access it. Even if you want to read Excel file, you have to open it. If you open it, it is coming to RAM to serve you. Clear? Clear till now, everyone? You see here, this is open. This is in my RAM right now. If I'll close this, Chrome is right now in my hard disk. Chrome is not open. I will click it now. It will come to RAM. See, something is rotating over there. It's taking some time, right? But now it is ready. I can do anything. I can click and it will respond. See how fast I can do now. So every single application comes to RAM to serve you. They cannot serve you in hard disk. They will launch in RAM, and that particular memory is specially kept for these processes. Every single process is happening. You can easily know what is happening, which are the applications right now running by just typing a simple command, that is task manager. You see, these are the applications still here. Ignore background processes, those are also in RAM, but these are the applications. These are the applications I have opened, and those are open now. Calculator, it must be somewhere here. Let me see, where is calculator? Here, you see, calculator is there. Then EM editor, EM editor is here. See, then Google Chrome, Chrome I just opened. Then you see Microsoft Office is, this is also opened. It's here only. Then you see Paint, Paint is opened. Clear, clear. I'm just
What is
giving
that
you.
case file, bhai?
Cache file is sometimes you have, for example, right now I entered something, I searched something. For example, I searched facebook.com. Now I will go and see in my history. History, It shows the recent things, right?
Yes, bhai.
Where is it bringing it? Where the Google Chrome is bringing it, and it is showing you from where it is bringing it. It is bringing from the cache file. I'm going in very deep, huh? Very basics, very deep. These are very, I mean, computer basics. These are not data engineering basics, which no one in this field will teach you. But I'm going to very basics. You just to understand the concepts. That is my hobby, or that is my thing. Whatever I pick it, if I am learning it, I have to go to the basics. If I'm seeing something here, this is an UI, user interface. This must be coming from somewhere, right? There is a background thing. I'll show you the difference. Now I'm closing it. I have closed it. See, Google Chrome got closed, right? You see, in apps, Google Chrome is not there. That
Yes,
means it
sir.
is no more in RAM. Now
Okay.
I will go and clear my cache files. Control S, Shift, Delete, Enter. Skip. Okay. Ready? Shall I open Google Chrome now? Shall I open Google Chrome now?
Yes, yes.
Shall you see if the history is there or not? Is it closed properly?
Bhai, in memory and RAM both are same or different? In memory?
Uh, it wasn't deleted properly. Okay, I think history things are in cache file. I think it is they are not put in cache file. In memory is RAM only. Yeah, that's CPU memory. You see the CPU memory, right?
Mm-hmm.
You see where is task manager? These icons are very new to me. Windows icons are, so I'm getting confused. I open task manager,
Why the
right?
Spark is running in memory? That's why it is faster, right?
Everything
Or
runs in memory.
yes,
Everything runs in
everything. Yes, sir.
memory. Spark is running faster. There is a reason. There is a bigger reason
Oh,
to it. The first
okay.
reason, basic reason, is the code Python. Python is very
Mm-hmm.
faster, very simple to learn, very faster.
Mm-hmm.
So Spark is built on Python, so it's faster. Then there are a lot of things which makes it faster. I'll come to that. So cache files are few things you are doing, no? Those are getting saved in cache files. So if you see when you launch, if for example your system got crashed, when you restart it, if you are doing something in Excel, it will give you some. Do you want to save this file? We have saved this before your system got shut down. On left, you will see some. Do you want to save this file or this file or this file? Have you ever experienced that thing? That it will tell you do you want to save it? For example, let me open an Excel. But I can't show you right now just because I can't uh, make my machine shut. So
The
few data here. If it's closed, I mean before saving, it got closed. If you are crashing means it is not getting saved. So it will bring that, it will keep some cache file in between. Whichever app is running now, those apps are having cache files in between. I mean, inside those cache folder. So there will be a lot of cache files normally get stored. So you need to clear it every time to make your memory cleaner. Yeah. So you are asking something, right, Ranjoy?
Uh, yeah, the best application of cache which I have seen is like, for example, in our Google Photos, if we have some backed up photos which we do not have locally,
Okay.
so whenever we open those photos, what Google Photos does is it creates a small thumbnail file of each of the photos
Uh,
and stores it
correct.
locally in our phone itself.
Correct. No,
So
that is the example.
yeah,
That is
you
for temporary purpose only.
you
That
guys
is
can
for
try that.
yeah, that is the for temporary
Delete
person.
cache. Yeah.
But the whole data engineering is a different one. This is a basic
Yeah,
computer
yeah,
knowledge. Basic
yeah.
computer knowledge. So if you can go and search Sagar, how what is cache
Mm-hmm.
files, and
Okay. Uh-huh.
I just gave you the basic gist.
But
How
suppose if I open Insta and I'll
okay,
watch a story,
okay.
after that, if I get offline, then again, if I'll open Insta, something will show.
That is
Is that
a example, pure example cache file.
okay? Okay.
That
Understood.
is already in your
Uh-huh.
local system. So if
Mm-hmm.
internet is gone, you can see
Mm-hmm.
your previous stories, but
Uh-huh.
not the next stories. The
Yes, yes,
stories
yes.
you have already watched, you can go
Yes,
back
yes.
and see them, see those, but you cannot see a
Mm-hmm.
new story. So that
Mm-hmm.
is a pure example of CAS. But
Okay.
Android, I think in Android and phones,
Mm-hmm.
to be honest, phones, they
Mm-hmm.
usually clean it. But in Windows, you have to clean it. There is no,
Okay.
I mean, a tool who is going to delete your CAS files. In Windows, you need to delete it via using commands, or you can go to the CAS folder, or you can use commands percentage temp percentage. So where we here, files in RAM respond faster. You know the reason now. Clear? Clear?
Mm.
Okay. If you do not save it to the hard disk, if you do not save it to the hard, okay, okay. This is mm, okay. I will cover it in another point. For example, you must have experienced. For example, if the file which you are working is getting larger, it might get hanged, correct? And you try to save it. Yeah, and you try to save it. Save it means it will save in hard disk, right? Correct. If you try to save it, it might get hanged. Sometimes you see, right now we are not seeing all this just because our RAMs are faster, our system OS has been very easy to handle all those applications. Our hard disks are from HDD, now SDD. I think everyone is having HDD kind of. So, excuse me. So slowly, the technology infra, everything has been changed. I am talking the things which are 15 years back, 2006, when Hadoop launched. So that time, these are the issues. If you remember, I can clearly relate to it. During my early days, during my college time, if I have opened a big file, if I have opened three, four games, applications like NFS, Vice City, or this IGI, all these applications I am running at a time, my system used to get hanged.
Yeah.
So that means the RAM couldn't handle to process that much of memory. Even that point of time when the FS image, see, I will come to that point. Just understand, if it's getting bigger, if it's consuming a lot of RAM, if the file is getting larger and larger and larger, if you try to save it, it will get hanged. It will not respond if your laptop is not that, of good configuration. But back then it was a genuine problem. It was a problem which you can encounter every single day. So I'll come to that. I'll come to that. Why these five facts? It was a fact at that point of time. If you are editing a file and it's getting bigger and bigger and bigger, while trying to save it, it might get hanged. You can lose that data. It will get hanged. It will restart, and you are going to lose that data. So, if your system gets restarted, then you are losing your data. Clear till now, everyone? Clear?
Oh,
Okay. So right now I will come to how docketing has handled FS image. First fact, client is faster. Who is client first? For FS image, I am right now designing the FS image architecture, or in coding, or how I will handle it efficiently, properly, and it will be faster. If something comes, it should respond faster, very faster. FS image is having all the data of the whole Hadoop system. Correct? Who is the
Yes.
client for FS image?
Gateway.
Correct. Gateway. Gateway will send, if will gateway will send any command, send any command or any request. Then FS image has to respond it faster, quickly as possible. And that can only happen if FS image is always opened in RAM. Clear? This is clear. You cannot save it. You cannot. I mean, you cannot keep it in hard disks always. And if you some request goes, then it will go to it will the call will happen to hard disk, and then the Excel file will open, and you have to wait for some time. Then the response will come. That is not a ideal. That is not an ideal solution. Clear, clear, clear. It has to be in RAM always opened, and it should be in RAM always. Till now, clear?
Yes.
Okay.
Yes, sir.
Okay, then every laptop will have RAM and HDD. It's clear. File in RAM responds faster. That is what we discussed now. Then, for example, if the file which is working, for example, a lot of transactions happening, a lot of data going in, going out, and everything is, I mean, everything, every single bit is being written or logs has been captured. Everything is captured in what? FS image, right? The chances, higher chances, it will get bigger and bigger in size. If your cluster is running for 2 days straight, 3 days straight, then imagine the size of FS image. So you cannot, there is no way you are going to save it. There is no option to save it. If you're going to save it, it will hang. The system will get hanged and you are going to lose all your data. You know how critical FS image is. You are going to lose every single data node's data, every single block's data, which block is sitting where are the copies, every single thing you are going to lose. Clear? So it is not an ideal solution to save FS image. We cannot save FS image to hard disk. Till now, clear?
Yes, sir.
Now I'll go to the architecture. How duck cutting has designed it very cleverly. What he ensured is it should be always in RAM, right? Correct. I will now create. Let me create the name node first. Let me create the name node. This is our gateway laptop. These are our data nodes. Let me now bring the second hero of this whole cinema. You have been asking, right? Secondary name node, where is it? Now it will come to the picture just to resolve that particular issue. Okay, let me connect all those. Okay, let me write it. First 2636. Hadoop 1.0. This is your name node. This is your name node. Okay, let me bring it to middle. Let me divide it into two part. Not that straight, but ignore. This is your name node. I divided it. This side is, for example, let it call this is RAM. जय श्री राम बलराम हो गया था. चलो इसको थोड़ा सा छोटा कर देते हैं. 26. Come on. This is RAM. And this side it is hard disk. I have just divided it to two parts, right? One side is hard disk, one side is RAM. All clear in figure, or you are having any question in this figure?
Here, bro.
Okay, let me name it. This person is quite important in this Hadoop 1.0. Secondary name node. Let me write it. Name node. Secondary name node. This is our gateway laptop or edge node. I'm slowly switching to the terms which are actually used in data engineering. Now I'm not writing gateway. That is also correct, but I'm writing edge node. Every system in our data engineering field is node. We call it node. When you call it node, you understand it's a machine. Okay, these are data nodes. I need not to do anything. Let me just give some color. This is RAM.
Why? This is the continuation of previous architecture, or is it
Correct, correct,
different?
correct, 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 correct. Same architecture. I have
Okay.
just showed you. I have just shown you I
Mhm.
mean the architecture part. I mean the block split part. I haven't came here how the FS image is handled. Today we are talking about the metadata management part.
Okay.
Yesterday we talked about how the block split happens, how the rule, what are the rules Hadoop has been, I mean Hadoop has set, duck cutting has set, that 3 seconds, 10 minutes, and three copies. Then deleting something, then again if someone is inactive, then delete that particular everything, whatever there is that in that node, then bring something and give it to that node. All these were how the data is being spread. Now I'm coming to how FS image is being handled properly. Is it's a very critical file. That is the concept. I'll just quickly do the coloring part. This is our gauge node. This is this whole is,
And
for
the
example,
present Hadoop architecture is different, right?
yeah, that is 2.0. That is
Oh,
2.0. Yeah. So this is okay. This is edge node, RAM, HDD fine. Okay, now I will come to one thing. For example, I will not start from the start. I'll start from the middle so you can get the clear picture. For example, the cluster has been running and it was stopped in between Saturday and Sunday. Clear? Saturday and Sunday it stopped, right?
Okay.
Then on Monday it starts. So by default, it's a file, right? It's a file, but we are always keeping that file on our
Yeah.
RAM. But it is inside hard disk, right? While we are launching in RAM, then we are keeping the data, we are not saving that data. But it
Mm-hmm.
should be brought from somewhere, right? It should be
Yes.
brought from hard disk. So I'll come to that. I'll come to the whole circle of it. Okay, this is the second color. Let me see if it's working. It's not working that way. Control G. This is the first color. Let's see the here the FS image is in hard disk. Here the FS image is in RAM. I'll tell you the details. Wait. Let me write. So why I'm spending time on these pictures? No, while going to interview, you'll just see those pictures, gallery. You'll get to know. You'll remember everything. It'll help you. Okay, let it be. I will not waste much time on it. Black. Let's do this. Then let me write F S F S, and I am okay. All good. Okay. Okay, now we'll get into the concepts. So I started my cluster. Like my cluster started, it was stopped somewhere in between. Maybe there were some data. So now my FS image will come to RAM. From where it will come to RAM? From hard disk it will come to RAM, right? I will whole circle you will understand. I am just going through the basics now. For example, late there were some already data, previous data from Friday. Not this color. Let me choose something else. There is already some data from previous sessions before it get closed. How exactly it came there into hard disk, I'll tell you. Now just imagine you open your system, but RAM has to access one FS image which should be in your hard disk, right? It cannot open anything which is not in your laptop. Can you open a application or file which is not in your laptop? You cannot, right? It has to be there, right? I'll come to how it goes to there. I'll come to that point. Clear till now? Everyone clear?
Yes, right.
This is
Yes,
the
right.
start. Okay, okay. I'm just starting it. So when the cluster starts, the file FS image will come to RAM just because it has to serve client. It has to be faster. The response should be faster. Clear? So this is the start of the day. Start of the day, cluster started. The file was in hard disk. It came to RAM to serve edge node. The same file opened and the same data is there. Now, the current day, I'm coming to the current day. Now on current day, then again, some transactions happened. For example, some transactions happened. Some transactions happened. Then, yeah, some transactions happened. So, name node will FS, I mean RAM, FS image in RAM will store it. Correct? It has to give the response, right? It's open there, but it's storing the data. I can open Excel sheet, I can write something. It can be accessible from outside, right? It's in RAM, my Excel sheet in RAM. If anything I'm
Yeah.
writing it, it can be accessed from any code, that file. Clear till now? But here you cannot save it to hard disk. To handle that particular issue, duck cutting launched another concept. Another concept that is edit logs. I'll tell you how it happens. Do not worry. That is edit logs. So duckcutting introduced another file which he named as edit logs. I'll tell you how it is going to play a critical role. What duckcutting did is duckcutting saved the same log in edit logs too. Understood? What duckcutting did is duckcutting saved the same data. This is current day. These two are previous data, right? This is current day data. What duckcutting did is duckcutting saved the. Is this the same? No, not this one. Which one? Okay, this one. No. What happened to my eyes? Okay, this one. So duckcutting designed this. I will keep another file. I will open it from hard disk. I will bring it to RAM, and I will keep the same transactions, same logs. Normally, call it logs in IT language. You slowly, please be familiar with these particular lines. We call it logs. Logs means some kind of some kind of data which you normally write in your accounts paper, or someone is selling something, they are writing something. Okay, I have sent this data, this data name, this block name is this. I have copied three blocks. Those three blocks names are this, and I have kept it in data node one. This second number I have kept in data node two. The third name I kept in data node three. These are the simple stuffs which I couldn't show you, else you would have understand. If IT Varsity works today, I will show you those how it actually, how you see those reports, those FS image reports. Now, till now it's clear. So duck cutting created another file, and duck cutting kept it in FS images RAM also, and the same data he wrote it in edit log, that there is another file, and he saved this, but not FS image. Duck cutting saved this data to hard disk. He didn't touch FS image. Clear till now? Clear?
Yes.
Any question? Sagar, Biswa, others? Any question? I'm ready to give another iteration if you want.
Yeah.
Clear, clear? Okay. So now what happened? So duck cutting, the cluster started. The FS image was in hard disk. The FS image launched. It came to RAM. It has all the edit logs, which are whatever the transaction happening. Today's transaction is the second line. And duck cutting introduced another file, that is edit logs. And the same transactions he started writing it in edit logs, and he started saving it, committing it to hard disk. Clear till now? Clear? Committing
Yes,
it to
sir. By same data from FS image, EL will store those data in hard disk.
correct, correct. I mean, not FS image. Edit log
Huh,
is going to hard disk, not FS image is
huh,
going to hard disk.
huh, huh,
Edit log data is getting saved. See, you
huh.
can see
But the
here.
data contains FS image data only, right?
Same
The
logs,
new
same logs,
Huh, huh.
same logs, exactly
the
same
For
logs.
safety
or
purpose,
Yeah, yeah, I'll tell
huh,
you
huh.
why. You see here both look same, right? Both of the side look same. Hard
Yes,
disk
yes.
and RAM same look same. But see here, does it look same?
No way.
Just because the cutting never wanted to save that particular the facts I told you. If FS image is that large, if you are going to save it, then it might hang, it might crash. So there is no chance of saving it. Then we will save it to there are a lot. I mean, FS image should be in RAM always. We need not to save it. We'll save it. We'll do a different kind of architecture to save it, but we will not straightly save it. It's continuous data going in, going in, going in. You cannot save that particular file, right? If I'm continuously I'm typing something in Excel sheet, then what is the purpose of saving it? There is transactions are happening every single time. I'm just telling you whatever I am training you, but in real world, transactions are happening. Like you understand, Swiggy, Zomato, even Zoom app right now. Zoom app is taking my audio right now. I'll show you that AI companion. Everything, whatever I take the class now, it give me a gist of it. Everything Zoom is taking it. Now Zoom will process it. Then Zoom will give me a overview of the class. Whatever you taught, Samir taught these things. Samir introduced Hadoop 1.0 today. Samir discussed about metadata management. Every single time the data is going in going out. The current time I'm telling. But that time it wasn't that quick or faster. That time even Android just launched in 2005 or 6. You understand my point?
Yes, sir.
Okay. So this is the, but duck cutting was saving edit logs, but not this FS image. This FS image is RAM that is not getting saved. This is not getting saved. Duck cutting was saving this edit logs to hard disks. Clear till now? Meanwhile, meanwhile, duck cutting, this was happening continuously happening, right? For example, 1 hour crossed. That is the architecture, that is the coding or programming which duck cutting did for that tool, Hadoop 1.0. After 1 hour, what will happen? I will tell you. After 1 hour, the edit logs. For example, I will take another transaction happened in that 1 hour. Let's just, okay, let's bring this color coding. Okay, let me do it. Another transaction happened. It got saved in FS image. So FS image is having all the transaction details where it will save again, where it will be kept again. I mean, in RAM we
Edit
usually
logs.
write. In RAM we usually write where it will be written again in edit logs.
Edit
Correct.
log.
Correct. But this will be committed. This will be saved to hard disk. Till 1 hour, it is getting saved, right? After 1 hour, what the code will do, that program will do after 1 hour, this particular edit log in RAM will go to, okay, wait, this is not the exact tool. Look at this tool. This particular edit log will be copied and sent to secondary name node. Clear?
Yes.
Clear? Clear? Understand these all are connected. Name node will just send it. After 1 hour, there is a code. It will send the edit log. It's still not touching FS image, right? Just because it's very critical, we shouldn't touch it. It has to reply back to gateway laptop and it has to communicate. Every single data is there. But we are in background, we are doing these things. This particular edit logs will be copied to secondary name node. Then the cutting design that clear these edit logs, clear these datas after 1 hour. It will copy to secondary name node. Then it will be cleared both from both. Understood?
So
And
secondary name node will store those data like history.
it's a kind of, we're just
Uh-huh.
saving. I'm just see,
Mm-hmm.
for example, I'm just copying this. I'm just opening another Excel sheet and I'm saving it.
Mm-hmm.
Understand? This is saving, getting saved in
Mm-hmm.
another computer. But after
Mm-hmm.
1 hour, that is the rule. That is the rule he has
To
set. After
avoid
one,
data loss, right?
for data loss only. I will tell you.
Mm-hmm.
You'll get to know what is
Okay.
the concept of it. Just I'm
Mm.
telling you right now the architecture. Then
Okay.
to free the RAM, see, FS image is continuously running. But what the cutting is doing, every 1 hour, it is deleting those data from the edit logs. It is not increasing the edit logs data. Every 1 hour, it is saving it, deleting it, copying it to a secondary name node. Clear? Clear? Just because it is, the cutting never wanted to give that much of load to RAM. Every 1 hour, he is cleaning the edit logs from hard disks, from RAM also. RAM is important, hard disk is not important, RAM is important. So he's clearing every 1 hour, he's clearing from RAM itself. So
So in
FSC,
secondary name node, it stores in HDD, right?
HDD, right? Yeah, saved in
Okay.
HDD itself. Yeah. So uh, then after 1 hour, this thing, two things happened. One thing is sending the copy of the edit logs till then that 1 hour to secondary name node, then deleting it. Two actions happened. The third action I'm telling you. Third action is third action, the SDDFS image will be copied and sent to secondary name node. Clear? I'm just telling you the actions. Clear? Then third action over. If you want, I will write those actions also in a separate or somewhere here. First action, second action, third action. If you are, I will reiterate it. Don't worry. Let me go through the concepts first. You will get to know. Slowly, you will get to know. Third action over. First action, copy it and save it in secondary name node. Copy it from RAM, send it to secondary name node. Second action, delete whatever there is inside SDD for edit logs, in RAM for edit logs, clear it out. Then third action, copy the FS image which was in SDD till now, copy it and bring it to secondary name node, copied it. Then fourth action, then the cutting this fourth action, then copy these edit logs, cut these edit logs and paste it here. Paste it with secondary name node. This part is over. Clear? Fourth action clear? I'll tell you by fifth action you will get to know what I'm telling.
Uh, Okay.
Okay, done. Then fifth action. Fifth action is this particular, but edit log file is there. It's emptied, cut and paste, but edit log file is there. I just don't want to bring a lot of, create a lot of confusion in your mind. Edit log file is there, but it's cut and paste, cleared out, and merged with secondary name node fs image. Fs image copied from HDD from name node. It came to secondary name node. Then the edit log after 1 hour, which was sent from name node, is merged with that particular file. Let me cut it properly. Control G, Control V, Control G. Once one cycle will be over, no, you'll get to know what is happening, what is the concept behind it, everything will be clear. A little tricky, but not that difficult. It's very easy to understand. I'll just let me complete one cycle. So this should be copied. So I have to now I have to clear it out. Now you see secondary name node is having the old data of FS image. This part is FS image. Don't get confused. The upper part is FS image in secondary name node. The lower bottom's part is edit logs. Understand this, right? This top line is FS image. This line is FS image. This part is FS image. Two FS image, one is three FS image. One FS image is in RAM name node, one FS image in HDD name node, one FS image in HDD secondary name node. Clear? Clear? Everyone?
Yes,
Yes,
bhai.
bhai.
Okay. Till now, everything is good. Fifth action over. Now we'll go for the sixth action. Sixth action is send this whole. Let me do it. Send this whole secondary name node, FS image in secondary name node X, and replace it with what is in there in hard disk. You understood? Fifth action or sixth action?
Yes, bhai.
Clear?
Yes, bhai.
Now see the magic. Now see the magic. Now I'll tell you the magic. Now, do you see these both are looking same after 1 hour?
Yes, bhai.
Yes.
Balance.
Balanced,
Balance.
right? Every 1 hour duck cutting designed, every 1 hour, whatever the transaction happened, the hard disk FSMS in name node will be in sync with FSMS in RAM in name node. Clear? Totally clear? Till now clear?
Mm-hmm.
Yes.
Yes, bhai.
Okay, I will go for the next transaction after 1 hour.
And the purpose, bhai, for
I'll
that?
tell you, I'll tell you, no, I'll tell you, I'll
No.
come, I'll tell you, I'll tell you. Then next transaction happens after few, let me choose the color, let me choose, let this be the color. After 1 hour, less few transactions happens. This is the transaction. So it will be where? It will be same written in edit log, and the edit log will be saved. It will come to hard disk, correct? Then again 1 hour passed. 1 hour passed. Let me keep it the second hour. Okay. Where is it? Next 1 hour. Do not judge my paint skills. After 5 years, I'm using it. Okay, let next 1 hour. The same color I've used. Fine. Okay, next 1 hour. Let me highlight it properly. Okay, next 1 hour. Again, some transition happened. You see this color, two colors, maroon colors. These two maroon colors are in edit logs. And in RAM, just because FS image, we are not touching, we are not saving, we are not copying anything, we are not sending anything, we are not touching. Everything is written in FS image and it's open in RAM and it's continuous process. All good till now? Till then, you don't click Control S, your system will never hang. If I'll fill this Excel sheet, I'll make it 200 GB. If I won't save it, till then my system will not hang. Till it's current file, right? It will keep on writing. If you are saving it, then only there is a load which will happen to RAM, and it will create another process to save it. Saving is another process. And that process, while handling those 200 GB of data, at that time it might get hanged. Are you clear till now? Till now, you are understanding?
Yeah.
So next hour, what happens? Something happened, some transaction happened, and the next hour is completed. Now what will happen? Well, tell me no, let me know. What will happen?
The data will be emptied from RAM and
No,
HDD
not
in the
empty
edit
from RAM.
logs.
No, first action, it will be copied first.
Okay,
If you
okay.
are going to empty first, then how will you copy it?
Mm-hmm.
It will be copied from RAM and it will be saved to, it will go to
Secondary name node.
secondary name node edit logs file.
Hmm.
Clear? Then the second action. Second
Delete.
action, dog cutting will delete both
Delete.
from
Yeah.
hard disks and from RAM too.
RAM.
Okay.
Deleted. Clear. Then the third action. Third action, whatever there is in hard disk, the FS image in hard disk in name node, it will be copied and it will come to secondary name node. Clear? Then fourth action, the edit log will be cut from edit logs. Control C V cut, and it will be merged with secondary name node FS image. This is cut already. This is not there anymore. Clear? Then the fifth action, this particular secondary name node, whatever FS image in secondary name node, will
Content setting.
will
SDD.
will will replace the name node, that's FS image sitting in SDD name. SDD of name node. This got replaced. Now again the same picture. You see, they're again in sync, right?
Yes.
After another 2 hours passed, again in sync. Now I'll come to the edge case. Now you can ask me a question: what if some transaction happened in between 1 hour and it didn't reach secondary name node, and maybe secondary name node crashed, or first, name node crashed. Something happened. Any one of both of the tools and both of the nodes, any single machine gets crashed in between that 1 hour. So I'll come to that scenario. How cleverly he has designed it. Let me
I
Okay.
think second point, right?
let
That's why he's storing edit logs in HDD too.
correct. That's
Of name
why
node.
he was storing this edit log in SDD. And
Yeah.
yeah, then some transactions happened. Let me
Mhm.
quickly show you. Some transactions happened. Clear? Then again, this is going to be stored in where? In FS image RAM, name node RAM. Same thing in edit logs RAM. Same thing will be saved in edit logs SDD, name node SDD, edit logs. And then in between, any of these machines, if this machine is getting crashed, for example, if secondary node is crashed, so nothing is there with secondary node, right? Secondary name node till now.
Yes.
After 1 hour, it will be sent to secondary name node, right? So
Yeah.
this is totally empty. Secondary name node has no role right now. Secondary name node has no role right now. There is no role involved. So this is not in picture. If secondary name node crashed even, there is no question about it. If it's crashed even, there is no use. I will come to that. I'll come to that. That point of time, even if this particular node gets crashed, for example, your name node gets crashed. There is no role of secondary name node. Leave it. There is nothing inside it. It cannot do anything. Even it's live also. Even it's active and responding also, it cannot do anything if your name node itself gets crashed. Correct, correct. If
Yes.
Nemnode crashed, then what will happen?
RAM will not persist the data, but
This
HDD will.
this this will not be
HDD
there.
is
This
fine.
data is gone.
Yeah.
Correct. This data is
Gone.
gone. This data is gone. This data, particular data. See, this
Yes.
Yes,
data
sir.
is gone. Right.
Mm-hmm.
But so it got crashed. For example, it got crashed. Now what is there in hard disk?
The
FS
same
image
data.
and
These are
edit
saved, right?
logs.
These are already in hard disk,
Ah.
right?
Yeah.
Mm-hmm.
Okay. So what? Oh, for example, it started again. Nemnode started responding. Nemnode started responding. I mean, Nemnode started again. It got crashed. Then it restarted. At that point of time, the code is what duck cutting designed it. It will go into a safe mode. It will go into a safe mode. It will take this edit log which is saved. Take this and it will merge it with the hard disk file. FS image hard disk. Edit log is sent to hard disk file and the hard disk file is now replaced by, I mean, merged. This particular edit log is merged. Now I will bring that data. Okay, let me paste it. Okay, Control G. Okay, let me cut it and keep it somewhere parked so I can use it later. That will be parked here. I'll come to it. So now what will happen? This particular edit log, what if it restarted, rebooted, the computer gets rebooted, this particular name node gets rebooted, then this particular edit log data will be merged with hard disk data. Hard disk data and if system restarts, there is nothing in RAM, right?
Yeah.
There is nothing in RAM, right? Till now.
Mm-hmm.
But I am keeping it till here just because to know you, there is no data loss happened. See this, both of this. Compare both.
Same.
Both the data are same, right? But there is
Mm-hmm.
nothing in RAM. But the same data which we lost is still there in hard disk. Clear?
Yeah.
There is
After
nothing in
that,
RAM.
the data will replace to RAM or
No. See, it started. No, it started. Just started.
okay. After
Started.
starting.
Started. It take the data. Take the logs from
From
edit
HDD.
logs. It
Yeah.
merged.
Okay.
Then it will launch that HDD file. See, my
Mm-hmm.
system started. My
Uh-huh.
Excel will not be opened, right? Excel will be
Mm-hmm.
opened after that. So this is not there. But I just let me take it out from here. This was the final FS image, right?
Mm-hmm.
This was the final FS image, right?
So the RAM
Now,
is empty right now.
of course, I
Uh,
mean, if you'll start your computer,
mm-hmm.
no application will be launched, right?
Mm-hmm.
All the applications will be on hard disk itself.
Okay. Okay.
Once you
No, I
start,
thought the hard disks will again replace those stuffs into RAM. I got.
there is nothing. There is no replace thing. There is nothing in
Okay.
RAM. It,
Uh-huh.
it, it will it will launch again that particular FS
Mm-hmm.
image which is sitting in hard disk. It will
Mm-hmm.
launch another Excel which is sitting in hard disk, but data is same. You see those data, both are
Uh,
same. There is no difference. The data which we lost while it got crashed. The data was in edit logs. The data is in RAM, but we lost RAM data. But edit log we are saving it continuously. Correct. So edit log will be merged with hard disk, and while starting, the RAM is no more there. This is empty. For your purpose, I just kept it aside to show you that there is no data loss happened. To compare both the data, it's same, looking same, right? So this is not there. It restarted, right? The name node got restarted. So there is no data. Clear? Now what will happen? If started, then of course FS image has to come to RAM. Then particular this file will open. If this file in SDD, hard disk drive, it is saved, right? If something is saved, if I'll control S, it is saved, right? If I'll open the
Yes.
same file, it will open with these data, right?
Yeah.
And
yes,
to
sir.
coming to RAM means you are opening it. I will open this file, it will come to RAM. Simply it will come to RAM. This particular file will come to RAM, and again the same process will continue. You understand now?
Yeah.
Again the same process, same loop will continue. This is edit logs again. Same process, same loop will continue. This is Hadoop 1.0 architecture. That's how the cutting designed it very cleverly, that he has not to save FSMS any single time. It will be opened. If the cluster is running, it will be running. Sometime it crashes, then in between 1 hour. If it crashes, then we have edit logs so here. We have edit logs here in this part. In this part, edit log is there, no? Come on. In this part, edit log is there, no? We are saving continuously, right? In hard
Yeah.
disk, edit log is there. This will
Mm.
merge with hard disk. Then both the data will look same. The data lost and the data in hard disk is
Why is there any possibility of HDD crash?
yeah. That is why Hadoop 2.0 will come. That is
Okay.
why Hadoop 2.0 will come. Hadoop 2.0 will come for that issue. All these issues. These are only one issue which was there very evident. To tackle that, Hadoop 1.0 they have designed in that way. It went till like 2012. It was all good, not all good. People are facing. There were a lot of times name node failures, a lot of issues happened. By 2012, Hadoop 2.0 came into picture. So at that time, what happened? I
So
think
when
I
all
have.
these things are automated,
Samir, I
we
have one
we
Yeah,
more.
need not to.
yeah. There is a program happening. Tool means you are. If I'm telling a tool, there is a program and code. There is a
Mhm.
logic happening in behind.
So the admin people will do all these things. Oh,
Yeah, it's already there.
okay.
It's already in Hadoop tool.
Uh-huh.
Admin people need not to change anything inside. There is
Mhm.
already code that is inside Hadoop tool that is already
Okay.
designed. What the cutting gave them to change is that config file. In that you can size the block size. That 120 I told, no, that can be changed. But these are the rules set for Hadoop 1.0. This cannot be changed. This is the same way it will work. The architecture is same way. It will go and it will edit log. It will take it will keep it edit log and it will be saved after 1 hour. It will give that edit log in RAM to secondary name node, and secondary name node bring a copy of the FS image in hard disk. Then it will merge it. Then it will replace it after every single hour, after each hour. And so after each hour, both of the logs, I mean both of the FS image in hard disk and RAM are in sync. But there is a corner case. The corner case is if before 1 hour name node itself crashed. If name node is crashed, then we still have edit logs saved in our hard disk, name node hard disk. It didn't go to secondary name node. It will go after 1 hour. But the crash happened before one hour. So secondary name node is having nothing. But the current edit logs are still there in SDD just because it's saved, continuously saving it. And this can be merged. So we are not losing any data. This can be merged to hard disk drive. So whatever the FS image is having and edit logs, whatever there is got saved in hard disk, it will be merged and it will the same data which we lost. It will the same data, then it will launch that file, FS image file, then again process will start. Again the data stuff will start, again the same process will continue. Edit logs with there will be something come to edit logs, then something come here, something come here, something come here. After 1 hour that will be copied here, then that will get deleted from these two places, and this cycle is going to continue. And then this whatever is there in secondary name node, that will go and merge with the copied data from name node hard disk drive, FS
Samir,
image. Yeah. That's
Samir, what if like after the edit logs are copied from RAM and HDD of name node to secondary name node,
Mhm.
then secondary name node itself crashes?
In that case also you have edit logs in your HDD, no?
No, like in HDD and RAM, both of them are getting cleared,
Okay. You
right?
are talking about that kind of case. Okay.
Mm-hmm.
If
Yeah.
secondary name node is not there, then
Mm-hmm.
after 1 hour edit logs. If secondary name node is there, then FS image will get to know. That's name node will get to know that secondary name node is not responding. It's a code
Okay.
based, right? If they are
Mm-hmm.
giving some copy and paste thing, they'll get the error. There are a
Okay.
lot of loopholes in this particular architecture, and
Hmm.
we'll cover that in Hadoop 2.0.
Okay, okay.
Let me see. Let me see if that IT Varsity lab is running right now. Come on, log in. Come on, launch, launch, launch. Yes, it's launching. You guys are having good luck today. Whatever thought of covering, I can cover that. Okay, my gateway node is launching. I clicked here. You remember this one? This will be redirected to my gateway node. You see this gateway node? That I am launching. Correct. I will go to my terminal first. File, new terminal. Okay, terminal. I launched. Okay, now tell me if it's my gateway. If it's my gateway laptop I launched now. You are saying it in, I mean, in a wave format, but this is a gateway laptop which is communicating. The yesterday the way I showed my how my VDI works, it is somewhere else, but I am communicating via internet. Now I am communicating to this gateway laptop via internet. Then how can I communicate to my gateway laptop first?
Putty exe.
No, 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 Putti.
No, Linux command.
I'm
Oh, Linux.
already I'm already in that terminal. No, I'm already in
Okay,
gateway
okay.
terminal. I'm not
Then
in
Linux
my
command.
Linux command. Correct.
Oh,
So present working directory. See, home.
yes, yes.
This is the user ID. I mean
Mm-hmm.
the system user ID. There you saw home slash Cloudera. Here you are
Mm-hmm.
seeing home slash this particular
Directly.
VDI name. Correct. Okay,
Yes,
let
yes.
me do some prerequisite. You need not to bother. I will tell you what I am doing right now. I'm doing some Hadoop commands. Hadoop fs mm, remove rmr slash user slash what is my username. This is my username. Control C, Control V. Star. Need not to worry about all this. I am going to cover every single
But what is
command.
the system? This
This
all.
is this is being hosted somewhere else. Diversity Lab is a US company, so
Okay.
they are having the systems and they are hosting this in, I mean, through internet
Okay.
using a web browser. So you can use virtual machines. Jupyter, if you
Like
have
we can
no,
practice there.
but it's paid one. It's paid one. Jupyter. Mm, virtual ID. You can practice in a lot of IDEs there, but they are very low weight IDEs. You can practice over there. I think this is one. Okay, VS Code is there. Okay, this is Jupyter. Let me launch it. It's a kind of IDE. See the same? Do you see the same thing here?
Yes, yes.
See the same
Mm-hmm.
thing here?
Okay.
Okay. So this is how they have done a lot of things to host it differently. Just because there is a lot of Hadoop and a lot of tools they need to install, so they are charging it. But I can build that, but it will take some time. This is my first batch. Once I'll get those headcount around 30 40 when I will be needing all this. I'll definitely, and there will be 4 5 10 persons maybe who is where they wouldn't be having that configured laptop particularly. And that time I have to host it here. I mean, for those I have to run the commands in here. I have to properly create a website. I have to use jupyter.com. I have to do a lot of research. This is not a single day thing. This will, I mean, take 6 months, 1 year, and I'm not getting time for me also. I am preparing for you guys. Then Sunday is a class, Wednesday is a class, Friday is a class, then Saturday, Sunday again classes. So I'm not getting time for me also. So it will take some time. It will take some time. Once I will cover two batches, complete two batches, I will have everything in my mind. I need not to prepare anything or tell anything you. Everything will be mind. I can directly see just the agenda and I directly start the things which I will not miss. This is a kind of virtual desk we are virtual computer we are accessing. But it's paid. It's paid. IT University Lab is paid. But you need not to worry. I will do all these things in Cloudera itself. We all have Cloudera installed, right? Not a single person. I think two persons are there in weekdays group. Are still not there. Trying to find a different option. I mean, different laptop, or someone is trying to buy another laptop. Okay, let's see. Now it looks good. Okay, let me see. Everything looks good. Present working directory from SAS user. Okay, let me show the long list of items. Okay, I can see the file. You can see the file, right? You understood this particular command. That is why I covered this command in the starting
Long
itself.
listing command.
Yeah, that is why I covered ls, ln, and pwd in the starting itself. When I am doing something, you wouldn't be in a confusion, in some doubts that what he's doing. That is why those three commands I started, just because you are going to see. But Linux command is not over. Your next class is Linux and Hadoop commands I will cover. Hadoop 2.0 will be covered around 1 hour, 1.5 hour. Then we'll directly start with Hadoop commands and Linux commands. Okay, now I did the long listing, correct? Now I am
Okay.
using this command. So this is a Linux command. So it will communicate to my gateway laptop. This command was a Hadoop command. I was clearing some data. So this command was a Hadoop command. See, starting I told you Hadoop FS is the prefix. You use it for 90% of case. You use it in front of those Linux commands. It will show you the same thing. It will work the same thing. It will work the same way. Let me show you. Hadoop fs-ll. See, it didn't throw any error, but it's showing something is inside. Okay, that is showing unknown command. Okay, there is nothing I think inside HDFS just because I cleared it. We'll see this, don't worry. But these are Hadoop commands. This is telling unknown command, not there are three things. Unknown command it will work, or else another thing that they threw you, right? I told you that there's a difference. It's working, but it's not throwing any error. But this is not working. It's telling me that the command, I think the particular word is the command is not recognizable or not something like that. But here it is taking it, but it's telling that unknown command. Okay, where are we? Where are we? We are in the long listing part. Okay, there you can see. This is sitting where this particular line. This is sitting where? Let me know. Let me know. This is the command I have. No, this is the command I have entered. You
Sitting where means why?
Where is this particular file or drive, or this particular file or whatever? The long listing means it will show you the file and drives,
Mhm.
right? Where
Inside
where is it?
student.
Where is it?
Student.
It is inside
It is in
gateway.
Hadoop.
It is no, it is inside gateway laptop. I am shooting ll command. It's a Linux command.
Ha 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 ha
It is inside gateway laptop.
ha ha ha
Clear? This
ha
file is in gateway laptop itself.
ha ha.
Clear? What is the size of the file?
205 MB
How do you know this?
and source like
Are you talking about this?
no.
Like the 2151115
Correct. This
matches.
is not, this is the name of the file. This
Yeah,
is the size of the file in bytes. Let me copy it. Let me show it. What is the size? Byte 2
2000 2 TB like
MB. No, it will be some 205 MB. I have written means it will be 205 MB only. Let me show you while doing conversion. Byte to MB converter. Converter. And Control V. What was the file in megabytes MB? 215
20.
something 11.
Yeah,
215 something else, right?
yeah.
Clear, you got to know the file size. It is showing here. This is the file size in bytes. It is always in bytes. Everything is bytes. The name of the file, I kept it as 205 MB zip. I can change it. This file must be somewhere here. See, this file is here. I can change the rename. I can rename it. It will change. It's not the size of the file. I can clearly rename it and it will show something else. 205.1, and a point is not allowed, I think. underscore is allowed 0.11 MB zip. Refresh terminal. LL. See, 20511 MB zip. I just renamed the file name. It is not the size. The size is this. Clear, clear, clear till now.
Yes, sir.
Let me rename it to 205 MB. 205 MB. It will. Okay. Okay. Till now we are there. Let me see if something is there in Hadoop. Hadoop. FS RMR slash user. User. Come on, this is the user. Control C, Control V, slash star. Come on, star, enter. What? Did I do any mistake in my command?
Auto spelling size, I think.
Hadoop spelling bhai, HADOOP.
Okay.
HADOOP.
Hadoop, come on, FS RMR slash user slash control V slash shift star, enter. Deprecated. Okay, fine. Nothing is there. Deleted everything. Okay, let me put it. Now, what am I doing is I am sending this file to Hadoop system. Okay, I am copying this file to Hadoop system. So I have to use Hadoop command. Hadoop command put 205. The name is mb.small zip. This is the file name, right? Okay, 205 MB zip. Hadoop fs hyphen put. Everything looks good. Okay. See how simple the commands are. Put means put it to Hadoop systems. Clear?
Yes, sir.
And we'll go in detail. The Hadoop command, Linux commands are there. I am just telling you how easy it is. Commands are how easy. You can understand it by writing it. Put means put it inside. Enter. It will take some time.
So bhai, in that same interface, we can use both the commands.
Yeah, if you want to talk to, see, Gateway laptop is connected to Hadoop. Hadoop,
Mhm.
you cannot communicate directly, but you
Mhm.
can communicate with Gateway laptop. You want to communicate with Hadoop systems, you have to use Hadoop commands.
So
It
in
will
this
take.
interface, we can use both Hadoop and Linux commands.
Correct.
Instruction
In
generally.
that single interface, you can Gateway will understand Hadoop and Linux commands. If it is
Mhm.
meant for Hadoop, it will send to Hadoop. If it is meant for Linux, it will do the Linux operations. If it's meant for Hadoop, it will do the Hadoop operations. So it took some time to upload this to send this 205 MB to Hadoop systems. Now you can see again my terminal started. Now what I'll do, I have sent the file to Hadoop systems. In the background, what would have happened? Tell me. In the background, what would have happened?
You firstly deleted the
No. I
corresponding
just,
file.
forget those things. I will just clear the
No.
Hadoop directory. Then I have put this particular file inside Hadoop. In the
Yeah.
background, what would have happened?
This process, bhai,
See
it's
this
stored
figure.
in data nodes.
See this figure first. What would have happened?
It will create three replications.
Correct. What is the
Mm.
block sizes? Tell me.
128,
128,
128
72.
and
72 plus 5, that will be 77
Ah,
around. That is what we know by theory. We will see that in practical, right?
yes,
Yes.
Okay, now I will generate a report. Hadoop fsck. What is the file name? 250 MB dot zip. What do I want to get? I want locations. Locations. I want the blocks. I want the files also. Hadoop FSCK 250 MB.zip, nothing is wrong. Again wrong. Hadoop command.
In the spelling mistakes.
That's what I'm correcting it. Okay, looks all good. Hadoop FSCK 250 space locations space blocks space files. Enter. This will generate a report. Wait. What did it tell? File not found. Exception file doesn't exist. Did I do any mistake? Hadoop. It's not 250 MB. How stupid I am. See, small mistakes. It will happen. If I am doing these mistakes, imagine the mistakes you will do. Hadoop FSCK. Hadoop FSCK 205. I have done 250 MB. See? Did you see on the I
By
have
hyphen you missed.
no hyphen I have given no. Instead of FS. This is not a Linux command. I'm directly going to see Hadoop hyphen where I put after Hadoop
Okay,
FS
After name.
after
Hadoop and FS.
Hadoop FS after Hadoop FS I put normally hyphen, so it will connect the Linux command. Accordingly, you will understand this is a Linux command. This is a pure Hadoop command I'm using to take that. I told you no 90% you will relate. 10% they are specially designed for Hadoop. I'm
Okay,
generating
okay.
a report in Hadoop system itself. From FS image, I am taking a report out. I will get to know what is there inside. I have pushed a file into it. I need to know where these files are sitting, what is the size of these files, what is the size of these files, where they are sitting, how many replicas of these files happened. All these things I want for that to know that I am trying to generate a report. That report will look something complicated, but you will understand. I will make you understand. Then I want the locations. Then I want those blocks. Then I want those files to enter. Okay, there is a report got generated. Oh, till connecting till here. File system inaccessible, not this one, this one. Connecting, Control C. We will analyze this report. Control V. Now you understand this report. What is this particular line mean? What is this particular line mean? Minimally replicated blocks.
Okay.
Two blocks. If it would have been if it would have been 260, then minimally replicated blocks number. If it had the file size would have been 260. 128, 128, 256 plus 4.
128,
3.
and the rest.
3. Then it would have shown us 3. Total blocks 2. Okay. Then I will come up. Total files 1. What is the size of the file? This was the size of the file, right? 205 MB. This was the size of the file 215115964. In the report, it's showing that this is the file size. Okay, I brought it. See, same file size, right? The file is this. Total file 1, total blocks. There might be, I can push another 3-4 files together, right? But that's what is giving all the details. Total files, 1 file is there. Total blocks, 1 file, 2 blocks. Minimal replicated blocks 2. Then default replication factor. What is the default replication factor? 3. Replications done 3. And rest is nothing. It's showing that everything is healthy. 205 with zip is healthy. Everything looks healthy. Now we'll come to the blocks part. Now see, this is the file 205 MB, the name of the file. I'm making you understand the report. As a data engineer, you need to understand this. You understand this? This is the file name, correct?
Yes,
Yes.
This is the file size 205 MB. Replicated, then replications, 3 replications happened, correct? But replications happened 3. But how many blocks? 2 blocks, correct? 128 and 77.
Yes.
Okay, done. Now this is zeroth block. In normally IT we start with zero, zeroth row, zeroth block. IT people can easily relate, but if you're non-IT person, it starts with zero. Everything starts with zero. Zeroth row, first row, second row, zeroth column, first column, second column. So it's zeroth block, then first block. Two blocks are there. Till now clear? You need not to bother about anything. Okay, I forgot to tell you. I'll show you that one. Another picture. I forgot to give you that insight. The Gateway laptop I have launched right now from IT Varsity Lab. That Gateway laptop is connected to a cluster which has three nodes, three data nodes, three data nodes.
Why is that data nodes are um, automatically created or we have to create
No,
them?
no, 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 no. It's all it all depends upon the admin people. How many data nodes they are going to give it to one cluster depends upon the size of the data you are going to handle. If the size is in terabytes, petabytes, then you need a lot of computers. If the size is 10 GB, 20 GB, then you can easily handle it in single computer. That is data node. Correct? Correct till now? Clear?
Yes.
Data node is storing but the IT Varsity Lab, excuse me, the IT Varsity Lab which I am connected to, that particular the cluster I'm connected to from that gateway laptop, that is having three nodes. Let it be 105, 106, and 107. Let it be. I'll show you that in report. Why I'm telling you 105, 106, 107, you'll see that in report. I am coming to that report again. Forget all these things. Forget everything. All things forget. These are for FSMS. You just see the block. This is the block name. Okay, this is the first block name. This is the second block name. These are all stored in FSMS. I told you, right? FSMS is storing everything. FSMS have created two blocks. It gave name to it. How it will recognize? It has to give name, right? Everything we need to give name, else we will not find it, right? Every single file we have to give name to recognize it. See, these are two unique names FS image is created. Correct? These two unique names are two block. BLK block. Block name is block something something. Clear till now? This is block name. Clear till now?
Yes, sir.
Now we will go to the first block length. This is length means this is the byte. This is the size. We usually use length in IT terms. Length of the file is they will calculate the size of the file. Okay, this is the size. I am taking it. I will convert it to MB. This is in bytes. I'll go to my converter. What is expected? Let me know. The first block, zeroth block. What is expected? Come on. Okay, this is byte. This is megabyte. Shall I have to refresh it?
128.
Exactly. Let me see if the data is something else. Control C. Let me launch another. What is it? I am not sure. Google is on something on how much high Google is. You see what is it showing?
Yeah.
Byte to megabyte. Google AI,
Yeah.
stupid AI. See, it's 120. That was why I got confused. Why it's showing 134? The same thing is showing. You saw the first block,
Yes, sir.
128.
128 MB.
What is expected for the second block?
କେତେ ଥିଲା ଯେ? 215 ଥିଲା.
205 ଥିଲା ତ 205 128 ଗଲା ତ
88.
77.
87.
77 is expected. We'll see that. We'll see that if it's that much or it is that's it or it's a different value. Control V. Exactly 77.1506, which it was showing, right?
Yeah.
0.1506 or something was there.
Yes. 205 point something. Yeah.
Yeah. See, this was something, right? It converted by 2 MB, it got converted 15 something. So you saw it's exactly, I mean, block has been divided. Replica, you see the replica of first block, I mean, zeroth block. Replica is 3. Where it is stored? Where it is stored? 3 blocks are where? One is in 172.16. I told you every single machine has a IP address. You
Bhai,
remember?
it was 215
Yes.
MB, right?
205 MB.
Oh, 20. Okay.
Oh, 205 MB. Let me show
Okay.
you here in my IT Varsity Lab. This is 205 MB. Clear? 205 MB
हाँ
size. Okay. Now here. So here the replica it's
Bhai,
showing
it was that name.
which name?
No, 205 was the name, right? It
205
was
was the
215.
name. 205 was the name, and
Yeah.
also,
No.
I'll show you the data it was and the bytes it was having. I'm
Okay.
copying this byte,
Yeah,
the
I think
size of the file.
Google
Google
gave us
source
the
Okay,
wrong
no. At
number.
that time, Google showed 215. That's
Yeah,
Okay, so
yeah.
Google is on roads. Don't
हाँ
think
Yeah.
of See 2058 it is. It's 205.
हाँ
So let me go to where here. So here you understood till now. So the live replica is 3. For zeroth block, there is 3 replica. But the 3 copies, by rule, they should sit in different nodes, different data nodes. Correct? Correct? Data nodes means, go come to this particular example. 128 is not sitting in a single data node. 128 is divided into three different data nodes. Correct? It cannot sit. You cannot keep double copy the 2 blocks in a single data node. It has to be replicated to 3 copies, and it should be in 3 different data nodes. Clear, clear, clear. Then I'll go to report. You remember this particular architecture, right?
Yes.
So by default, it should be in 3 different data nodes. Every data node is a machine, right? So every data node will be having a IP address. Now look at this particular first one. Data node info with storage. Look at the first one, 172.161.106. It is the IP address of that data node. Clear? Clear?
yes, sir.
Okay. Then second data node comes in picture. This is the IP address 106, then 107. Then we'll see the third one, 105. The zeroth block has 3 copies and they are sitting in 3 identical nodes. Those 3 nodes are different. Clear, clear, clear. We'll wrap it up soon.
Yes,
Clear?
yes.
Then we'll
Yes.
go to the first block. I mean the second block. Second, but by in IT terminology, it's first block. Zeroth block and first block. Two blocks are there. The second block length we saw already. We verified it. It's 77 MB. Then where it is sitting. Live replica is 3. It is sitting first in 107. Come on. One sitting in 107 and the sitting in 106. Here you see highlighted. I have highlighted it. 106. Third one was sitting in 105. Clear? So by this image, all the design is like this. The data were sitting like this. They have 3 identical nodes and they are maintaining 3 copies but in 3 nodes. See, 120 is divided into 3 copies and they are sitting in 3 identical nodes, not in a single node, correct? Fine with the Hadoop architecture. 72 is sitting, 3 copies are there and sitting in 3 different nodes, correct? That's what it is there. 105, 106, 107. There are 3 different data nodes and both files are divided and they are sitting in 3 different data nodes. Clear? This report has nothing else. This is what we wanted to know as a data engineer. Clear? Clear? And this is what the exactly here also I can show you. It will look a little confused to you. This is the same thing here. I've just Did some formatting over there, replicated, replication 3, blocks 2, okay. Zeroth block is this 106, you can see. Then first one is 106 for zeroth block, then the second one is 107 for zeroth block, then the third one is 105 for zeroth block, 105, 106, 107. Then the first block is sitting in 3 blocks, length is this much, then live replica 3, then we see it is sitting in data node 172, 107, this one, 10, 107 first, then the second one is sitting in 106, then the third one is sitting in 105. These are the IP address of those data nodes. Clear? Anything confusing
Yes,
till
sir.
now? Anything
No,
confusing? Total
no.
clear?
Why
All clear?
that blocks means 0, 1, 2. Like this wise
That
it will
that that
start.
was
Okay.
that's how it will show. Zero means the first block. You take it.
Okay.
Everything starts with zero.
Okay. Understood.
In IT, everything starts with zero. Zeroth row, zeroth
Mm-hmm.
column. Even in
Mm-hmm.
Excel also, this is not first. This is not first. This is
Acha.
zeroth column. This is zeroth row.
Okay. Mm-hmm. Understood.
So that's what let's not close this. I have to take the same class tomorrow for a weekdays batch. So I am not closing anything. Let me end the Zoom meeting. Now questions, please. Anyone having any questions? I can reiterate once more. I can again show you the architecture. I think the image itself is enough to make you understand, to give you, you just go and just see once, not today, before Saturday's class, you just go and sit for 10 to 15 minutes, see the architecture part, how it was having, how it was, I mean, the edit logs and those FS images, how they are in loop in every 1 hour. If the name node crashes also, the logs are stored in hard disks, they can merge, and we will come what are the failures, what are the challenges in Hadoop 1.0. We will see, we'll Hadoop 2.0, what are the different possible solutions came into picture, and docketing brought it in 2012 after 6 years. So let me see where is my meeting? Okay, here, let me stop it.